Hello dear students. In this video we will learn what is Char data type and its properties. So as you see, when we declare a variable like this char x, then this is read as x is a variable having data type char or character. We have in earlier lectures we have seen what is int and float data types and also double. Now all these are numeric types because whenever you declare any variable of these types, then you can store some number in that particular variable. The first time we are learning that what happens when x variable is of char data type. Now such a variable can store any one character. So in this variable x, you can store a character like a or capital A, let's say, but only a single character can be stored. Now the question here is, we now know that x can store one character, but the question is, can x store a character like hyphen? Just think over this. Well, what character? What is that we are talking about? What do you mean by x storing a single char? Can x store this dash? Of course, yes. Now, at first instance, many beginners feel that or think that when x is a char data type, x can store only alphabets like A, B, C. Not necessary. Look, we have not declared anything like alphabet x. We have written char x. By char x, we mean that it can store any valid printable character. So can x store comma? Yes, of course, comma is also a character, but any such single character can be stored. So that's what has been written. X can store, say, A or capital A or any such character. Even it can store hyphen or greater than. By the way, can x store 2? Now you might say that 2 is a digit and we have said that x is a character. Of course it can store 2. When you store 2 in x, then this 2 is called character 2. It becomes a character 2. Any digit can be stored, but only a single digit can be stored inside a char variable. So when you declare a char variable, you can store any printable character, or rather you can go to layman's language and say the character which is there on the keyboard. Any such character can be stored. So how do you input and output a char variable? Like how do you input integer? You use scanf %d, isn't it? Or how do you input float? You use scanf %f or double %lf. Like that, there is a format for entering a character value which is %c, obvious. %c will be the format used in scan and print. As an example, let's say in this program we have declared a char variable. Now you know x can store one character. And let's ask the operator, let's flash a message, enter some character. Now user is entering some character because there is a scanf. And just imagine user enters a character such as, let's say, A from the keyboard. So to input this single character, we use the format %c. And of course, the rest is ampersand has to be given in scanf if you want to scan the value of x. Now, finally, you can print whatever you have entered just now. You can print the value of x using %c format. So if user enters A as the input, then the output will be you entered A because the value of x is A. So remember, if you are entering a character from the keyboard, then you use %c, and if you are printing a character on the screen, you use %c. Now some more fundamentals of character data types, or rather some more, no, many more, is that you can even initialize a char variable. If you want, you can initialize a char variable to a single character. Like consider this line. Now you know char x means x is a char data type variable, and while declaring we have initialized it to A. This is like we often say int s equal to 0. We have declared s of integer type and we have initialized it to 0. Like that, characters also can be initialized But just be careful when you write the constant character on the right hand side of equal to, you have to enclose that character in quotation, that to single quote. Many of you might call this as apostrophe, but characters are always enclosed inside the single quote. Note, it is a single quote, it's not double quote. I mean, strings are written in double quote. For example, if you have a string like hello, this should be written in double quote. But we are not talking about string at all at this point of time. We are talking about a variable that can store only one character. And whenever you are storing one character, that character should be enclosed in the quotation. So this is how you initialize a character. So what do you say about this? Char z is equal to quotation 3. Perfectly valid. So z now is a char variable and it is storing digit 3. But that digit 3 is stored in the character form. It is stored as a character constant, you can say. So 3 gets stored in z. Don't call it as a number now. It has become a character. Okay. Now next thing is that every character has a unique ASCII code. Now this point is so important, because all our concept of char data type will revolve around this code. Well, the point is, if I ask you, is that does our computer know A, letter A? You would say, definitely, sir, it knows letter A. My answer is no, it does not know letter A. Yeah, it does not know the letter A. It might sound funny from my explanation that the keyboard has that button labeled as A. What happens when you hit that button? It's just an electronic button that you are hitting, like a button on mixer grinder. So when you hit that button A, some signal is generated. Of course, the button is labeled with A, but some signal is generated which is passed to the microprocessor, and then it identifies that some key whose value, a particular value has been hit, and then it maps that particular value to letter A and it literally produces A on the screen. It's like, if you still feel that machine knows A, B, C, D and all that, then it's like talking to your mixer grinder in English. Come on. Our machine, computer knows only two things, 0 or 1. It deals only with binary numbers. So, how do you understand these ASCII codes is that capital A actually is recognized by ASCII code 65. Even not as 65, the binary equivalent of 65, which is 1, 2, 3, 4, 5, 6, 7. Check that these are 7 bits and this is 65. This binary is 65 and one more 0 we will pad up to make it 8 bits. So this is how A is recognized by our computer. Or capital B is 66, just one value more than value of A. So obviously capital C will have a code 67 and such capital Z will have 90. Check, all these letters, are simply recognized by their codes. So what about small a? You might feel that small a should be same as capital A. Capital A is 65, so small a should be 65. But small and capital letters are discriminated by our machine. Small a has ASCII code 97 and small b will be 98 and small z is 122. Okay, and listen, there are more characters, that, like there is hyphen. Hyphen is also a character, so it will also have ASCII code. This character has ASCII code. Then asterisk, yes, greater than symbol, less than symbol, all these are characters. All these characters will have a unique ASCII code. But the point is, we can't remember all the ASCII codes. There are so many characters. We can't remember all the ASCII codes. We remember some common codes. If you remember capital A is 65, that's enough. Up to Z, capital Z is 90. And if you remember small a is 97, that's enough, because small z will be ultimately 122. But many other characters we can't remember. One more ASCII code you should remember is 0 or ASCII code of 1 or ASCII code of 2. I told you now these are digits written inside the apostrophe. So they have become characters and they will have ASCII code. By the way, ASCII code of 0 is 48. ASCII code of 1 is 49 obviously, and it goes on up to 9. 0 to 9 digits also have ASCII code. Okay, even that escape key, escape character we call it as, which is in the corner of the keyboard, labeled as ESC, escape, even that character has ASCII code. By the way, I will go ahead and say even F1, F2, F3, those keys which are called function keys also have extended ASCII code, but we are not learning that in this particular chapter, or we will not touch the extended codes. But that is what is ASCII code. Every character is recognized by ASCII code. Okay. Now comes the most important point here. Just check this line again. X is equal to A. X is equal to A. So I am saying that X should store small a. X is a character variable. And that's correct because I have written that. But what if I say X doesn't store small a? X stores 97. Oh, good Lord. What is that? Check that A is a character and every character is recognized by ASCII code. So when you are assigning character A to X, its ASCII code gets assigned to X. So internally, you please try to understand nothing called small a is stored. Everything is recognized by their ASCII codes. So what if you say Z is equal to 3 here? Z is equal to 3. Then you know that ASCII code of 0 is 48, 1 is 49, 2 is 50, 3 is 51. So actually what Z stores is ASCII code of 3. Okay, let's try to understand it more. Just check this. This will be very interesting. Check that we can print char variables. You know, whenever we print char variables, we use %c format. But we can print char variables in %d format also. You know, %d is used for printing integers. But if you have a character variable and you want to print the value of that character variable, you can either use %c or %d. Let's check this code. I have character X equal to A. Check the initialization. Now, you may say that X is storing A, or you may say that X is storing 97. Both are equivalent because small a actually is recognized by the ASCII code. Now, what will be the output of this printf, which I am marking? This printf is using %c format to print the value of X. Obviously, the output of this will be character A. Isn't it? The quotation won't be printed. The character A will be printed. And what about this printf? This is printing a decimal. Check %d here. And whose value it is printing? X. But what is X? Small a. Again, what is X? Small a. It is 97. So you are now printing decimal value of X. So that is going to print 97. Tell me, isn't this 97 ASCII code of the character which was stored in X? Isn't it so? So you recall on the page where I was explaining ASCII codes, I said I don't remember ASCII code of hyphen. Yeah, really I don't remember. I don't remember ASCII code of asterisk. Or so many characters are there. I don't remember their ASCII codes. But is it necessary to remember? Not at all. By the way, whose ASCII code you want? You want ASCII code of hyphen? Then what you can do is just give me some time. What you can do is you can just initialize a character variable. Please give me some time. You can just initialize a char variable to hyphen. Now tell me this printf %c is printing the character. So this is going to print the hyphen on the screen. But the next printf is printing a decimal of X. And whatever is its ASCII code, I don't know what it is. But whatever number the ASCII code is of this hyphen will be printed. So a C programmer can instantly find out what is ASCII code of some character, and we don't have to remember any ASCII codes. Now the next point. Character variable can also be initialized with ASCII codes. Just check. If I write this line char x equal to 97, just check this. Now this is too much. I have declared x as character and I am initializing it to a number. But I hope you have directly understood this. This is equivalent to saying char x equal to small a. Basically 97 is nothing but small a. When assigned to a char variable, hello, just don't get confused here. If I write int y is equal to 97, then this 97 is not small a, because whom are we assigning 97? We are assigning 97 to an integer variable. Then y is purely a number, 97. But look at this. I have a char variable x and I am assigning 97. Then character a will be taken by x. And now if you print this character in %c format, this is going to print a, which proves that initializing x to an ASCII code will definitely give that character stored in that variable. Of course, this method won't be preferred by any programmer. Well, if you wanted to store a inside x, then this method is best. You simply give the character, isn't it? The character a in the apostrophe. I mean, who is going to remember ASCII code of small a is 97 and then assign 97 to a char variable? But the fact is that this also can be done. Character variable can be directly assigned an ASCII value. The last thing in this particular video is coming up. What is the last thing is you can increment or decrement a character. Yes, just check this code. Char x equal to small a. Okay, so you tell me what is x. You will say x is small a, or you can say x is 97. Basically x is 97. Get convinced with that. Because there are no characters, everything is treated as ASCII codes. Now the next line says x plus plus, which means x is 98. Just check, x is getting increased by 1. But now if x is 98, then x was a, but now x is b. I hope you are understanding. In simple sense, when you increment a character, then we get next character in the sequence. And the next character in the sequence after a has to be b. But please try to understand what's happening when you increase a character. The ASCII code gets increased. And previously we were saying x is 97, but now we are saying x is 98. If x is 98, then x is no more a, x is now b. So this printf %c character, while printing x, is going to print b. That proves that initially x was storing a, but now x is storing b. Of course, you can decrement a character. After this, if I say x minus minus, what will happen? What is x at the moment? 98. It will again get back to 97. But now if x is 97, then x is no more b, x is small a. So if you again print the value of x, it will print a. So incrementation and decrementation by any amount is allowed. For example, instead of saying x plus plus, you could have said x equal to x plus 2. If you said that, then letter C would be printed because you are incrementing the variable x which was initialized to small a by 2. So it will give next to next character in the sequence. So I hope some fundamental properties of char variable are very well understood. See you in the next video with more discussion on character and on strings. Thank you very much.